So this is an example of a small-scale hydroelectric facility. So a community plans to develop a small-scale hydroelectric facility. It is anticipated that the facility will supply electricity to 800 homes, where the average power consumption per home is 1.5 kilowatts. The facility will utilize a river with a width of 10 meters, a depth of 2.5 meters, and an average flow rate of 2 meters per second. The head associated with the dam is 6 meters and the generator efficiency is 87%. So the question is this a reasonable plan? So basically you're building a dam so that you can power the village around that dam. So in this case it's around 800 homes. So let's list down all the given in this problem. So what are the given? So I'll use the black one. So the given are, so we have a number of homes. So we have 800 homes, 800. And then we have average power consumption. So average consumption is equal to 1.5 kilowatt per home. Okay, so that's so I should write it better. So kilowatt per home. Well, this is 800 homes or houses. The facility will utilize a river with a width of 10 meters, a depth of 2.5 meters. So the river cross-sectional area, so if this is the river here, so the cross-sectional area is in terms of basically this part here. So the width is 10 meters, so this is 10 meters and this is 2.5 meters. So the area cross-section of a river is equal to 10 meters times 2.5 meters. So that is the area now, which is 25 square meters. And then what is other given is 2 meters per second of velocity, so or flow rate. So that's in terms of velocity. So in that case, velocity of the river is equal to 2 meters per second. All right, so these are the given now. So what are we going to find? So let's find, the question is, and then there's efficiency, which is 87%. All right, so we're going to see if the plan is reasonable, or the plant or the hydroelectric facility is reasonable. Is it able to provide the power needed by the 800 homes? So what's going to be the solution for this one? All right, so let's start first with how much is actually needed for provision of energy for 800 homes. Okay, so in order to do that, we have to find out what is the required power, P required for 800 homes. All right, 800 homes. So what is the required for? So we can select that one, or we can check this one by number of homes times the power consumption. Power consumption per home of each home, right? So we are all given now. So 800 homes times 1.5 kilowatts per home. Right, so we have canceled that one, so we can get the answer of 1.2 megawatt electricity. All right, so this is basically the amount of power that is needed to be or the minimum electricity coming from the hydroelectric facility should be 1.2 megawatt of electricity. Otherwise, then it's not feasible for that power electricity plant to provide the power needed. So now let's now solve on for the amount of electricity provided by the facility. So how to do that? So of course, what is power? What is energy for that dam? Energy is basically the potential energy, which is mgh, and in terms of power, we can say E over T again. mgh over T is equal to M over T times GH. So basically it's the same. So in this case, we are given with the height. The height is given. The gravitational force is also known already, is a constant. But we don't know exactly what is the mass and what is the time. So this is basically the mass flow rate. So we can have this as mass flow rate. So we don't know this one, right? But we are given these two already, and we can multiply this one with efficiency. All right. So in order to get power, we need to know efficiency is given. We need to know this. So what is this mass flow rate? So mass flow rate is N over T. Okay, I will put it here. M over T, which is basically the mass flow rate, normally is M dot, can be solved by density times volume flow rate. So in this case, if you put this one into unit analysis, density is kilogram per cubic meter times cubic meter per second. So basically, kilogram per second is the answer for mass flow rate. So that would be the unit for mass flow rate. So this is a correct formula. But density is known. This is water density, so it's a constant for water at a certain temperature. But Q is not given. But then we are given, if you look at again the part here, we are given the area and the velocity, right? So basically Q is just, so I will just put it here to save the space. So Q dot is equal to area times velocity, which in this case, all right, area is 25 square meters times the velocity of 2 meters per second. All right, so we can get 50 cubic meter per second. So that is now Q. So Q is now known. All right, so now we can get the M over T, which is rho Q. So we can put these two into the original equation. So we can say P is equal to M over T is rho Q. So we can put rho Q, which is, okay, rho Q times GH times efficiency. All right, so I can put now all the values. So rho Q is, this one is now this one. So 50 cubic meter. Oh, that is not the rho Q. This is only Q. So we can put, sorry about this, rho. Rho is density of water, kilogram per cubic meter, times Q, which is now given here, 50 cubic meter per second, times G is 9.81 meter per second squared, times H. How much is H? The height is given here, 6 meters. So we forgot to put the height here. H is 6 meters. So this is 6 meters times 0.87, which is the efficiency. So the answer for this one is 2.56 megawatts of electricity. So this is the answer for the power that is generated by the hydroelectric facility. So if you look at this answer and the power requirement, so we can say that the P generated which is equal to 2.56 megawatt of electricity, is greater than the 1.2 megawatt of the power requirement. All right, so required power. So therefore, the answer for this question is the facility is sufficient, okay, to meet the electricity generated for electricity need for the community. The electricity need for the community. Okay, sorry, it's a little bit messy, but you can see the process there. So this is now the final answer for this problem.